All right then, so let's get started. Thanks for joining us for our session, Python for Full Stack Web Developers, Turning Your Ideas into Products. And this is our third session. Let me introduce our speaker, Katerina. The next slide. So Katerina Hanson is a senior engineering manager at Kojo, a procurement solution startup. She has multiple years of experience managing large product teams, as well as a background in project engineering. She advocates for a balance between agile and waterfall processes for a smooth project workflow with the visibility. All right, Katerina, I'm going to hand the microphone over to you.
All righty. So I'm going to recap a little bit what we've done so far. So what are we building? We're building an open source menu and ordering system that can tie into delivery apps and client apps. This is going to be a single tenant backend, potentially with peer-to-peer discovery. And we've created a number of project documents so far. We've talked about product requirements documents, PRDs. Those are usually delivered by the product manager. They answer, what are we building? And they'll usually develop a list of product specifications. So what's in and what's out for this project. After that, the lead engineer usually gets a hold of the technical design document and develops that. That describes how are we going to build it. It defines the technical approach, any interfaces, the technical specifications for it. Out of the technical design document, usually I look for a work breakdown. Basically, what do we need to do? A solid enumeration of the tasks and the tickets associated with that, along with something of a size. Story points are great, but like how the relative size of things leads into a project schedule that usually the lead engineer or the EM might develop to answer the question of how long is this going to take. You lay out dependencies, resources, and order of operations, and you can track the progress against the plan. That's what I really like to use something like Tom's Planner for. Optionally, you might use a process flow diagram to develop a flow chart of user activity. In that case, you're probably using your favorite diagramming tool. I like Lucidchart. You could also just use PowerPoint. You may get wireframes from design. The wireframes will illustrate components without any specific design. Especially for standing something up that is very quick and fast. Usually wireframes are sufficient because you're using some kind of a design framework. So that's really where you get to the unblocking the programmer. You really want to have at least wireframes. And then we could also do architectural model or database diagrams. I wouldn't say that those are necessarily required in every case, but it's very useful to helping people understand the direction quickly. So I have this repository. I have added to the repository project document templates in a markdown format for each one of the ones that I've just talked about. I've also updated the specific project docs in that repo for this particular project as an example. And I have added a series of tutorials that are going to go into literal step-by-step detail on what the different things that we're about to talk to today. So those are all found in this repository. So deploying. Deploying was a trick. I have deployed a few things before in my career, but I am not typically the person setting up deployments from scratch. The last time I deployed something from scratch, it was basically manually get yourself an EC2 instance, SSH onto the EC2 instance, pull your GitHub repo and like launch it from there. And then that was basically it. So I will say that going through this exercise demystified a lot of things for me about AWS and the systems and how they kind of work together, what's manual, what isn't. And I think it also really answered the question of why have companies started going towards infrastructure as code recently, and it's because there is potentially a lot of clicking. But the goal of this past session was really to have a production-like development environment. So this is not something that I would say is what people would be hitting in production, but it should be very similar. Enough that there's only a few like final steps to kind of get it over the line to scale. You know, the development environment in all other ways should be secure, like a prod environment. We should set up roles and permissions. We need to understand what we need to do to scale it out without actually doing it. It should be easy to use for the developers. So my goal was to update the remote environment on a push from main without any like manual developer intervention. And it's also really basic. So I'm not using Kubernetes. I don't want to abstract away from the actual hardware right now. So some tips that I found from going through this exercise. Amazon has basically things that are kind of like objects or pieces of the puzzle, and then like containers to put them in. And at first I started off with a very much like, okay, let's start with the high level thing and fill that container with stuff. And that turned out to be the exact opposite way to do things easily. It's almost always better to build up the individual components first and then pull them all together in the container. The other thing is like, don't be afraid to delete things. There was a whole lot of, well, I picked the wrong version of that. Let's delete it. It's not working. Let's try that again. Let's rename it. Let's rename it back. So like Amazon does not have any problem cost-wise with you spinning something up just to delete it right on back. There are oftentimes Amazon will pop up little alerts with links in them. It's really important to open those. The first couple of times I missed them, and that turned out to be also very bad because I lost the link to the thing that it was trying to point me to. A lot of the defaults are fine. As you're kind of going through stuff, it's usually a good idea to go check and make sure that the defaults look fine. But if you don't have like a good reason to change something, I would generally recommend leaving it the way Amazon has set it. There were definitely a few different UXs, so user experiences, that tripped me up on the first pass through, specifically around S3. The permissions model was unusual compared to the other UXs. And then setting up the AWS, the CLI was surprisingly tricky. I'm just on a Mac. I tried to follow the directions. It wanted me to do all kinds of things. It specifically said, don't use Homebrew, but I used Homebrew anyway, and it worked just fine. So that was a fun little amount of time spent. All right, so for the purposes of this, I'm going to start at GitHub. GitHub has actions. So we already had a Dockerfile in place. And the first thing that I realized was that the Dockerfile that I had in place for my local Dockerfile would not do for production deployments. I needed a whole new Dockerfile. Specifically, I needed to run Django like without the manage.py run server commands. Django doesn't do well on its little local development server in a production-like scenario. So the typical way that you usually set up Django in a production scenario is with a WSGI server, in this case, Gunicorn. There are others that you could pick, but Django works really well with Gunicorn, so why not? And then Nginx. You also need to start worrying about production environment variables. And of course, you have to set the debug equal to false. There's warnings all over Django about don't run this in production with true. And then, like there's some static files for serving. It is an API. You'd think there wouldn't really be all that many static files, but I ended up with some static files anyway, so may as well set those up now. So for a little bit more information, Nginx is an open source web server. And in this case, we're using it as a reverse proxy. It can also provide a certain amount of caching. It's event-driven, it's very scalable. It allows for many threads within a single thread, which, if you're familiar, Python does that very badly. So it is really nice to have a thing sitting in front of it that is helping you do multiple threads. So Nginx specifically, we define, and I'm probably going to have to flip in and out of this page a few times here. Okay. So what did I add? I added for Nginx, I added this, and I'm going to have to zoom in here. And we all know how much my computer loves to zoom. Oh boy. One second. This is increase font size. Okay. So this is basically what I want to show you. So we had the original Dockerfile. And I'm just going to close everything else here. And I'm going to close all these too. All right. So this is my original Dockerfile. So you can see what we're doing is we're pulling Python. We're copying the requirements.txt over. We're running pip to install the requirements. We add the project directory, copy it over, and we're pretty much good to go at that point with the Dockerfile. For the production Dockerfile, it is similar, but we start off with a few different things. I started off with running an apt update and an apt install Nginx. And then I set the working directory, copy the requirements over, run pip, copy the whole project. And then I copy in this nginx default.conf. That goes in etc nginx conf.d as the default configuration. Then you need to copy and set the permissions for the script that I also created here. And we copy that over and run chmod on it. And then we need to expose port 80, which is the typical HTTP port. And then go ahead and just run this command. And this command is going to start gunicorn and Nginx whenever the container launches. So that's why we use command here. And this is just to kind of like sum it all up, put it in one spot. So if we look at Nginx, this is the default conf that I have. So this is a fairly standard copy of an Nginx config. A few things to look at. It is listening on port 80. The server name I originally had in here, I had 0000 because I did not have a DNS name, but since I have registered a DNS, now I can put my DNS in here. I have the root as source static, location static is going to alias just source static, and then this location is going to forward anything to 8,000, and 8,000 is the port that is usually runs on, Django usually runs on. And then we've got our access logs and our error logs. They're going to end up in var log Nginx access and error logs. So if we ever need to SSH onto the machine, that is where we're going to go to check our error logs. All right, so that's the Dockerfile, that's Nginx. This is the run sh, and so the bash script. Basically, these are the commands we're going to run on the Docker start. We're going to go ahead and use Python 3 manage.py migrate to migrate our database. And then we're going to do gunicorn server.wsgi application, and we're going to bind that to 8,000. This and at the end is going to leave that command running in the background so it can continue. And we just go ahead and unlink the etc Nginx sites enable default, and we kick off Nginx with this daemon off. Now, a lot of this I found references to, but now that I've tried it, it works. That is how you get it going. So not too terrible. Alrighty. So I'm just going to, I'm going to go back here and just pop open this and move it over here. I think that'll be how we do this. All right. So that's Nginx. Just to remind people, a forward proxy is a server that forwards requests somewhere else. So like a proxy, you call it and it forwards it somewhere else. A reverse proxy sits in front of the server and forwards requests to one or more servers. So it's still a proxy, and they call it a reverse proxy, but it's because it's sitting in front of the destination instead of directing you to a destination. And then yes, gunicorn, production app server. One of the questions that I had was really, why do you need both? But the architecture that I went looking at basically said, you need something to execute the Python because Python's not great at this. And that's basically gunicorn. But you still need something upstream to handle the requests that Django should not be handling. And whether that's, blocking people or because they're spamming you or trying to get in, or that you want to redirect it to somewhere else for static files, that's basically Nginx. And so this is a fairly classic 3-tiered architecture there. And that is kicked off in run.sh. All right. The next big thing that I did was moved environment variables to a file. So I added the .env package so that we can set up to load environment variables from a .env file. This allows us to use separate files for different environments. And it also gives me the ability to host the production-like environment file on S3 with encryption and lockdown permissions. And then I don't have to check it in anywhere. I don't risk people seeing my secret keys. So as part of that, as part of that, here now I have and basically what we do is we add from .env import load .env, and then this will load the .env file into the environment. And then after that, all I have to do is os.getenv secret key, and this will be a place that I can set environment variables that I'm only going to use in one environment or the other. So I have a number of them in here at this point. It's even going to let me move over to my production Postgres. So I can use my local database locally and my other database. And so neither one of these are the environment files that I actually put into production. So that's why they can kind of sit here. But also I can add them both to the git ignore so that they will never be checked in. And then I can kind of modify them locally to my heart's content, and yeah, just make sure that at the end of the day, the keys get updated if I need to in S3. Okay. So that was that. Okay. So then GitHub Actions. The first thing to do to kick off a GitHub action is make yourself a .github directory. Your action definition is defined in a YAML file. GitHub provides some nice examples. So I didn't know that, but there's a whole little browse repository thing for having GitHub actions do things that you typically want to do. I found one for deploying to ECS, which is exactly what I wanted to do. And it basically had a local task definition JSON file for deployments, and all I needed was a set of inputs for the definition for the file set up, and then I could add those, and GitHub will, on push to main, go ahead and run off and do the task. The one thing that I did need to do was add AWS credentials to GitHub in a safe way as well. And just another little thing here. That is this guy. So this directory, I put it in a workflows subdirectory, and then this is my GitHub action definition. So deploy to Amazon ECS, on push to branches main, obviously configurable. Here's the environment variables I needed to set. So this was part of setting up things manually on AWS, getting the information, and then coming back here and telling it about it. This is my task definition. So I could just put it right here where the path is to the task definition. And what's it going to do? So it's going to run on Ubuntu latest in environment development. And the steps, it's going to go ahead and check out, configure the AWS credentials. It's going to use the AWS access key and secret key that I gave it, the region that I'm defining up here, log in to Amazon ECR. So ECR is the Elastic Container Registry. And so it needs to log in there, build, tag, and push an image to Amazon ECR. So it's going to, every time you deploy to main, it's going to build you a new image and push it to the ECR repository that you've created and tag it. And then it will go ahead and build the Docker container off of my dockerfile.dev. So had to make sure that it's using the right Dockerfile. And then it's going to push it. And then it's going to do a little echo here. After that, it's going to fill in the new image ID in the Amazon ECS task definition. So it creates you a task definition based off of that. And then it's going to deploy the task definition. It's just going to kick off the task basically in the service, in the cluster. And then we're going to wait for stability in the service. And if all of that goes well, then the action is going to turn green. So I'm just going to log in here and show you kind of what one of those looks like. 1 moment. So here I am in my repositories. Here I am in Women Who Code FS with Dev. And these are the GitHub actions. So what happened? I kicked off a deployment and this last one failed because the service was not in a stable situation when it finished here. But we can see what it did. It kicked off the job. It did the checkout. It did the credentials. It did the login. It built, tagged, and pushed the image. So we can see it going through its Docker steps here. That's fine. This is the one that takes the longest because it does go into running pip install requirements. So we can see that kind of going on. And then copying it on over, we can see it running each of the pieces of the Dockerfile that we defined. So that's good. It filled in the task definition. And so there was definitely something that went up where the service was not ready for it. So we're going to go look at that in a bit. But first, let's kind of go over the AWS components. No, forward. All right. I know this is a bit of an eye chart, but this is basically the system that I built. So from GitHub, oh, no, don't do that. No, don't do that. GitHub has a role permissions that allows it to create the Docker container, push it to the ECR registry, and then go ahead and kick off a task, a service task. So it talks to the service, it kicks off the task that it just kind of created with the Docker container, which pulls in the image from the ECR registry and creates, it plunks the Docker container onto the Amazon EC2 box that I've defined. And then this Amazon EC2 is set up to be able to talk to the database. It's set up to be able to talk to the S3 bucket. These never really change, so you really do only have to set them up once. And then the client is going to have a certain amount of permissions that's going to allow it to access the API or the bucket. One of the things that I did run into, and I'll talk about it in a bit, was setting up that initial Amazon EC2 definition. That was a little bit tricky, but I ended up using the dev console and then turning that into a special AMI that I used afterward. So starting off with AWS, you can always make yourself a new account. I was a little uncertain about this, but it totally worked to do email plus alias in order to get a brand new special account just for this project. The new accounts, you get 1 year of free tier service, which is great to play on if you're careful. You don't actually have to spend a lot of money. And the watchouts for that is leaving things running when you don't need them. Getting lazy about security. That's really hard to clean up after the fact. So even though you're a solo developer, it's good to use best practices. And you should also go ahead and set your budget when you first get into your account. So AWS has IAM, which is your identity manager. By default, you're root, and you should never stay on root. You should always make yourself an IAM user. You should put your users in groups and give your groups roles. You should generate new SSH keys and don't use old ones. And you can totally have temporary role access for computer users. You don't have to give them specific IAM user authentications. You can just give them the temporary role access. And so that kind of looks like this, in the sense of like, there's groups, you kind of want to keep everybody relatively neat with permissions on the role that the user is in, so that you can add and subtract people as they come in and help you or leave. And then the computer user has temporary security credentials, basically, that allows it to do deployments on demand. S3 allows you to create buckets, which are directories, to store objects, files. So all the buckets must have a unique name worldwide, which is kind of silly, but that's okay. You can put basically any files you want in there. You can host your static files in there. So straight up JSON, HTML, CSS, you can just dump your whole website, like front end of your website, into a S3 bucket and set it open to the world, and people can go, and that's how you get access to people's static websites. And it turned out also to be useful for like backup, storage, and encrypted files. So we're going to be using it for static files and also the environment variables. RDS is the database. It's a stable static box. It's not going away. You don't have to worry about it like EC2 is very ephemeral. Your RDS, you want it to stay around. It does need its own permissions, and it's easier to build your database first, confirm that you can connect to it, and then like use secure credentials and security settings kind of going forward for your box to connect to it. But that was one that was like, just get that piece up and running. Don't try to generate it because you're only going to do it once anyway. The EC2, yeah, AWS did not provide an AMI out of the box like that had everything that I needed on it, but I was able to use their Linux 2 version, log in, modify it, and then create my own AMI to use ongoing, which this allowed me to make sure that the ECS agent was installed and logged in. I could install Docker so that it was already on the box, because I can't use Docker to install Docker. And then I was able to set up an SSH user and troubleshoot a bunch of stuff. And then once that was all set, I could basically delete my special Snowflake box. So I can just generate new boxes ongoing. So EC2 are basically, they're instances, literally remote servers at the core of them. You can totally SSH onto the instances. It contains, like the EC2 instance has in it listeners, security group, and like VPN subnets are defined on that. And then it's also defined by the AMI and the ECR image. And then that instance is a member of an auto-scaling group, and it is like behind a load balancer. I tried to do it without a load balancer. I really did. I thought I could get away with it, and it turns out that I could not. The load balancer was super important. It made the DNS available. It does health checks, and it ensures that the service has a status. So that error that you saw probably has something to do with the health checks not being good, and so the service does not have a good status on it right now. DNS, I ended up setting up the DNS. It was $11 to $13 a year. Route 53 was surprisingly easy to get a DNS from. AWS Certificate Manager also gives you a free certificate, so that was new. That gets you HTTPS, so you want that. It is more secure. And then the certificate is region-based though. So I originally accidentally created the certificate in the wrong region. I was able to delete it and put it in the right region. Don't be afraid to delete. It does take some time to process and propagate though. So it like can literally take a couple of days. So if you're going to do this, do it earlier rather than later. Yeah. So then this is like the container registry. This is really where you store your Docker snapshots. You're going to manually create a registry, and then it'll be there. Private is fine. You give it a name, and you give it permissions, and that's basically it. This one was pretty easy. And then the Elastic Container Service starts with a cluster. You want to define it to be ECS, not Fargate. Fargate was a total rabbit hole. You give it a service. It's easiest to just attach the service to a load balancer. And then the task gets kicked off. It runs the task definition, which is defined in JSON in the repo. So far, the service has been super finicky. It was a little better with the load balancer. The cluster took a couple of tries to create, and the service I've been basically recreating fairly regularly. My suspicion right now is that it does not work very well with a T2 micro instance, which is the free tier service. So I'm going to end up going and investigating that a little bit. That was the wrong button again, but that's okay. This is basically the AWS tour. So I'm going to pull this up. One second. All right. Direction. I did update my schedule with the different statuses and tasks that I had kind of been working on and things that I wanted to work on. So this is basically backend work. This was the bulk of what I would call the infrastructure work. This is today. So next, my plan is to tackle permissions and user authentication and sign-in in conjunction with some updates to front end. And so this is really where the front end app is going to kind of take off. We're all set to be able to deploy the front end to our in our deployment along with everything else. It'll probably get its own little GitHub action. And yeah, that's going to be the next major milestone. It'll be seeing some front end. And yeah, this is basically what I'm aiming for when I get a schedule, so then I can kind of track where I am against it. For instance, right now I know adding Swagger was the last big backend thing that I was planning to do. So I did. There we go. That's better. To get around having to deal with the static files right now, I made a script locally that will collect up the static files and push it to AWS. So yeah, that is a very direct deployment straight from my local machine, but it does give me Swagger. So that's kind of fun. So now I do have Swagger stood up, which should be nice for a certain amount of developer documentation, just kind of like right out of the box. So you can try out, calling for a location. Oh, and it's empty. Yeah. Cool. But yeah, that's nice. Okay, yeah, so that is probably something that I'm going to have to fix because it's going to cancel.
And yeah, this was great. Thank you so much, Katerina. I know you're like powering through like all of the content. I'm just like, you're like, oh, it's fine. It's just like I'm always in awe like how much of like the information you like synthesize, distill, so it's like easy to understand, but it's like a lot.
I hope it is a lot. There's a whole bunch, like that one went, but like yeah.
Okay. And like you said, yeah, you had documentation about AWS.
There's a lot of documentation.
Yeah, so
highly recommend trying it yourself because yeah, it should not be scary. It's a lot of clicking, and yeah, configuration, but not a whole lot of like logic.
Okay. Yeah, well, this is great. Thank you so much, Katerina. Some people saying thank you in the chat. Wishing everyone, good morning, good afternoon, good evening, wherever you are. Hope you enjoy the rest of your summer weather. Have a great rest of the week.
Yeah.
Okay. Bye.
Bye.